Okay, let's not waste more time. I believe some of you are still busy with this question, but because of time, let me question. You will compare the answer you obtain. Hello?
Hello.
Can I do the question?
Yes, please.
Okay, so let's start with the first one. So the question was about to find the sum of each of the following infinite geometric series. I believe you can all be able to identify the infinite geometric series by now. This is the series that you are given. So now the very first thing you will need to figure out is the formula that we're supposed to use in that case. Out of 4 formulas I've given you for calculating the summation, you must be able to pick the correct one that we're supposed to use, of which in this case, because we are talking about the infinite geometric series, you need to use this formula, and it's the only formula you can apply to solve this kind of questions. Okay, after using the formula, what will be left for you will be to get the first term of the series and the common ratio of that series, of which, if you are smart enough, by having the summation like that, you can be able to spot out the first term, and you can also be able to spot out the common ratio. But I don't want to take any shortcut at this stage. Let's go straight to the expansion first, and then from there we pick up the common ratio and the first term after the expansion. Because if we take the shortcut, sometimes shortcuts may lead us to the wrong answer, because this value, it plays a crucial role in determining the first term. Let's see how we can figure this out. From the sequence that is given, let's find the first term. How can we find the first term? We go and check the starting point. The starting point in this case is r equal to 0. So it means where we have r, we're going to substitute 0. And we know any number to the power 0 is 1. Therefore, it's going to be 1 multiplied by 9, which in this case, first term is going to be what? To be 9.
9.
We have seen how we obtain that 9. Then we go to the second term. How are we going to get the second term? We then substitute the next number after 0, which we know is going to be 1. We substitute 1 here. So in other words, it's going to be 9 multiplied by negative 2 over 3, of which that gives us an answer of what? Of a negative what?
6.
It's negative 6. Yes, exactly. And what could be the next term after 6?
Plus 4.
Yes, plus 4. And then after 4?
Minus
8 over 3.
Minus 8 over 3. So now you can see that the signs here are alternating. You must expect that a lot in geometric series. You're going to come across a sequence with the negative signs and the positive sign. Even under the arithmetic series, that happens. So you must expect that. Okay, then from there, I believe all of you can be able to identify the first term. Now let's see how we can get the common ratio. So the common ratio we obtained by saying term 2 divided by term 1. Don't make a mistake of leaving out the negative sign. The negative must be there at all times. So here is going to be negative 6 divided by 1, of which if you divide -6 by 9, it's going to give us the answer of -2/3. Eh?
Yes.
Yes.
Yes, exactly. And then again, it's the same as saying 4 divided by -6, which must give you the same answer. If it is not giving you the same answer, it means the series you'll be dealing with will not be a geometric series, because it's only the geometric series when you divide you must get the common ratio. So now from this series, you can be able to see that the first term here is 9 and the R is -2/3. Are we all together up to that point?
Yes.
Okay, then now let's substitute back to the formula. So it's going to be S infinity equal to, the first term is 9 over 1 minus, and then the R. You can see I'm using the brackets here. Why am I using the brackets? Because this R is coming with what? The negative. So I'm protecting myself against the negative, because negative, it may lead for us to get the wrong answer. So just put the brackets to make sure that you remember that this negative must multiply with that other negative. So this you can then put into your calculator. What do you get when you substitute this into your calculator?
27/5.
27. Yes. That is the answer we are looking for. So what does this answer mean? This answer simply tells you that when you sum all these terms from geometry series, you are going to get the final answer of 27/5. That's simply what this series tells you. Can we go to this last question we have on the board?
Yes.
Okay. Now, again, whenever you see sum to infinity, it's only one formula that must come into your mind. This S infinity equal to A over 1 minus R. 1 minus R, yes. So that's S equal to A over 1 minus R. You only need to substitute the information you are given. The question requires us to find the common ratio. So this is the common ratio that we have there. Okay, let's substitute and see how we get to the answer. So the question requires us to find the common ratio. So what is the common ratio here? Is this. We want to identify this ratio, but you can see you are not given any a series. Therefore, you need to take advantage of the formula, because we are having enough information where we can be able to get to the common ratio that we are looking for. So the summation to infinity we are given that is equal to 9,000. And then the first term is also given in this case. The first term we are given as what? As 1,000. And all this must be divided by 1 minus R. Your task now is to make R the subject of the formula. So you can do it in other, in any way you prefer. But I can tell you that from here you can go, you can get to the final answer by using different approaches. But myself, let me adapt a simple approach which you can use here. So that approach could be to cross multiply here, because our target is to make this R the separate formula. Let's cross multiply and see how we get to the final answer. So it's 9,000 into 1 minus R equal to, and then here 1 multiplied by 1,000 is going to give us the answer of 1,000. Then now, from here, there are different approaches again. The simple approach which you can take would be for dividing both sides by 9,000, because you can see this is inside the brackets. So it's two terms which are multiplying to each other. Therefore, you are at liberty to can divide both sides by 9,000. But if you don't like to divide by 9,000, you can then decide to multiply every term inside the brackets by 9,000. And then from there, you make up the simple formula. Let me take the simple approach, of which could be to divide both sides by 9,000. Because if you divide both sides by 9,000, this term and that term, they're going to cancel to each other. And you're left with 1 minus r, which is equal to, and this side, 0 cancels with 0, 0 with 0. Therefore, you are going to left with 1 over 9. You take 1 to that side, it's going to be negative r equal to 1 over 9 minus 1, of which is exactly the same as, say, 1 minus 9 divided by 9. So this is negative r equal to negative 8 divided by 9. Then the negative, you can multiply both sides or you divide both sides, is the same. You're going to get r, which is equal to 8 divided by 9. That is the answer we are looking for, of which you can confirm with the answer you obtain from your side. That is how you're supposed to attend to the 2 questions I've given you for today. If you did not understand, this is your time to ask me any question before we wrap up today's lesson. Is there anyone who's having a question regarding what we have covered up to so far? Okay, you're all fine, huh? Okay. Yeah, I think there's someone who needs to ask something. Okay, in the absence of the questions, let me tell you some good news I received today is that all the students I was teaching last year, all of them, they passed mathematics with a mark of starting from 60%. The lowest scored 62 and the highest scored 88%, of which I believe is going to happen even to your group of this year. So my target is to make sure we get a score of more than 70% to all of you. So that good news, it must happen to you guys. But I will want you guys to engage me more, especially on WhatsApp, because that's where I can be able to interact with you frequently. Whenever you are stuck with certain question, don't hesitate to let me know via WhatsApp. Are we all together on that? Yes.
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 You talk to me. Yes. Otherwise, for today, let's end here. We are going to meet on Thursday, same time, but we'll be covering a topic under Euclidean geometry. Yeah, we're going to cover Euclidean geometry. So otherwise, for today, let's end here. Have a good day.